Okay, so today we're going to be looking at some start geometry. We're going to be looking in our textbook at two sections, sections 1.1 and 1.3. Basic definitions, midpoint, and distance formulas. The main thing I want to talk about on geometry right now, before we start, is what is, I believe, the purpose of geometry in mathematics. So, although there's geometry relationships that we're going to be looking at, angle relationships, shape relationships, and all that stuff that comes along with geometry, I think its main purpose is to teach you to start thinking math in terms of cause and effect. So a lot of what we do is you're going to be presented with some information, or you want to show your work and state something to be true, or this leads to this, two items, this process leads to the next process. But mainly you have to be able to give a mathematical reason why. Why can I state what I'm doing? How do I know that this follows from this? This information leads to this conclusion. How do I know that? What do I have to base that on? What mathematical reasoning do I have? Not personal feelings, but actual mathematical information. So geometry is full of definitions, theorems, and notation, all of which is designed to help you come up with your reasons. Okay? So, because there is a lot of these things, and it's better that you know these, the more that you know these, the better that you are in geometry. It is recommended that you create a note page for definitions and a separate one for theorems. There's a lot of them. Okay? And this is your reasons for things. So you want to have them readily available to you. If you mix them all up, and then it's kind of hard to find what you're looking for. If I know it's a theorem, I can go there. If I know it's a definition, I can go there and find it fairly quickly. But that's up to you. You can decide how you want to do that any way that you want. So the first lesson here is about a lot of definitions that start us off. Definitions and other things that we'll define for you. So I'm just going to open this up and let you look at it. Here is a compilation of a bunch of stuff from these lessons that we need to know, and the notation that goes with it. So it's like a foreign language here. A lot of stuff going on, and so you want to have it like a vocabulary page is next to you. We're going to talk about a point. A point is usually designated as a dot. It's usually written with a capital letter. We have a line. Line usually is like something that looks like this. It usually has 2 points on it. The name of the points don't matter. You can also have a letter outside. This is a lowercase l. It can be any letter we find. It's usually lowercase here, capital letters for points. This can be labeled as line L. Or if I want to use the dots, the points to name this line, you need 2 points to name a line. Then it would be AB. And the symbol across the top of AB is a double arrow, and that means it's a line. So that symbol means this is a line. Then we talk about a plane. Okay? Plane is a two-dimensional shape. It goes on forever and ever and ever in all directions. They usually draw this picture like this. They can use a single letter in the corner, or they can use 3 points to identify that this is a plane. And you would write plane M, or you can write plane X, Y, Z, or whatever orientation of those letters you want. What is a segment? A segment is part of a line. It is the part between two endpoints. So the endpoints will be labeled. Okay, and this symbol, notice it's the AB again. A line has arrows. If there's no arrows, then it's called a segment. If I want to talk about the length of this segment, then I don't put any symbol across AB. So just AB means the length of segment AB. You have a ray. A ray has a starting point and then a direction, because the next letter, it starts at A and goes through B. So the way you write this is important. When I write ray AB, notice there's only one arrow across the top. A is the start, and it goes through B. That's how you would have to write. You can't write this as BA because that's not the same thing. Because the first letter in array indicates the start point of the ray. Opposite rays. AB is a ray, AC is a ray. Okay. An angle. There's a lot of ways to name an angle. So here's an angle. This is the actual angle. Is the space in between these two lines, just so you know. The lines are just the sides of the angle. So I can label it as, sometimes I'll put a number in here. That'll be angle 2. You can label it by the vertex. That would be this B number here. If there's nothing else around it and it's very standalone, you can label it by the vertex alone. We'll talk more about that later. And then you can also label it with the, usually it's the 3-letter name. A, B, C, or I can label it C, B, A. They're both the same. And notice that B, which is the vertex, has to be the middle letter. So in a 3-letter name for angles, B, the middle angle, the middle letter is the angle vertex. If I want to designate the measurement, so what actually is the measure of this angle, then you would put a little tiny lowercase m in front. So this means the measure of angle 2. So what is its measure? And for this point in our math career, we'll be using degrees. Okay? So that's some basic notation that you're going to be coming across that you want to be familiar with. It is very important that if you see something in the course of doing problems or whatever that I have not talked about, that you bring it to our attention as a class so that we can address it and add it to our list. Sometimes in this textbook and other things, they will assume knowledge that you may not actually know. So if you're not sure about something, it is vital that you talk about it so that we can address it and bring it to the known world with everybody in the class. So here's some other things that are going to be coming across. A postulate. What is a postulate? A postulate is a statement that is assumed to be true. And here's an example one. Segment addition postulate. So as math people, we call it a postulate because we are just assuming and acknowledging that this is quite obviously true. See, in math, they prove everything, okay, except for postulates. These they assume to be true because it's just common sense kind of a thing. So here's the common sense. If I have a line that has these 3 dots on it, these 3 points, which by the way are called collinear points, points on the same line, A, B, and C are called collinear, then I know that the distance between A and B plus the distance between B and C is the actual distance between A and C. The distance of AB plus the distance of BC is equal to the distance of A to C. This is a postulate. It's obviously true. You have another one for angles called angle addition postulate, and it does the same thing. Here are 2 angles right here. If I take this angle measurement, ABD, and add it to the measurement of DBC, then I get the measurement of the whole angle, ABC. That is the same concept as the segment addition, and that is angle addition postulate. So these 2 statements are assumed to be true. They are postulates. We're going to be talking about things called congruent segments. What is a congruent segment? A congruent segment means that the segments have the same measurement. And so they're going to use symbols to indicate these things to you. They're not always going to tell you that it is, a direct statement that this is our congruent. For example, you could see a picture that looks like this. And this segment has a little mark on it, and this segment has the exact same mark on it. If they have the exact same mark on there, then they are indicating to you by that mark that these 2 segments are congruent. And this is a congruent symbol. It's pretty small, but you can see that it's an equal sign and this little tilde on top. This is the congruent symbol right here. You'll see it quite often in this class. And it means 2 different things. Congruency means that the shapes or the objects are similar. This symbol right here means similar, and that they are of equal measure. So they look the same, and they have the same measurement. And usually we refer to this as the same size and the same shape. Same size and same shape. So that's what congruency means. So segments or objects are congruent. Objects are congruent. Measurements are equal. Don't put a congruency between when you're talking about measurements, because that's not the same thing. Objects can be congruent. Measurements are equal. If I say these are congruent, I'm also telling you that they are equal in measure by the definition of congruency. Okay? Congruency means that they have the same measure. Okay? So that's some things, little subtle stuff in mathematics that we'll talk about in more detail as we go along if it causes some issues. All right? So let's take a look at some other information we're going to be doing. Congruent angles. So in this case, I labeled the angles as a single letter angle. And again, they'll put symbols inside here like this to indicate that they would be congruent. If there are different symbols, see this one has 2 lines, it's hard to tell, but this one has 2 lines, and this one has 2 lines, 2 arcs in there, then they are congruent. If one had 1 and the other one had 2, then they would not be congruent. They have to have the same exact symbol to indicate congruency. And so because they have this mark in there that is the same, then angle A is congruent to angle B, which means the measurement of angle A equals the measurement of angle B. So when I say this, I can follow up with that. Why are these measurements equal? Because they are congruent. See? Cause and effect. There is a reason why I can say something. Okay? And so that's how we're going to be working some of these things out. So that's the introductory part. That's the basic definitions and some words that we want to use and some symbols that we're going to have to get familiar with. This is why you want to have these sitting on a piece of paper so that you can recognize them when you see them in problems and such. The 2 kind of problems we want to be able to do is to be able to find a midpoint and a distance. Okay? And so I'm going to show you this, the midpoint segment. What does it mean? Show you how to find it, and then we'll do a couple of problems for it. The midpoint of a segment. The middle of the segment. It's a point on the segment that is equal distance from the 2 endpoints. And this is the midpoint. That means this distance is the same as that distance. And the reason why I want to know that is because if I know the midpoint and I know it's in these are 2 the same distances, then I can say that this segment from P to M is congruent to Q to M. That's kind of why we want to know the midpoint for the most part. Plus, we just want to know in generally where the middle is. Okay? Here is the midpoint formula. Since the point is in the middle of 2 other points, then this just tells you how to find the middle. It's an average. Okay? What's the midway between, what's halfway between, 5 and 7? Well, we know it's 6. If I have a number line, here's 5, here's 7. Where's in between? Well, I know it's 6, but how do I show it mathematically? Well, if I take 7 plus 5 and divide it by 2, that's 12 divided by 2, that's 6. And that shows mathematically where that middle is, at 6. We just do it for points. We just do the x points and the y points. We find the average of those 2 things. So you take the 2 x's, you add them together and divide by 2. You take the 2 y's, add those together, divide by 2, and you have the midpoint of that segment. And so here is an example of it. So I have one point at -5, -1, another point at 3, 2. So I take the x's, -5 and 3, add them and divide by 2. Then take the y's, -1 and 2, add those together, divide by 2, and look what I get. This is going to become a -1. This right here becomes a 1/2. And then when I look over here, well, where's -1, 1/2? And sure enough, that's where the middle is, isn't it? And everything lines up where it's supposed to be. So that's how I do the midpoint formula. Now, this one I'm showing you is the distance formula. And they developed this through the Pythagorean theorem. So I'm showing you what they have in your textbook, but I will show you then how I usually do these problems, because I don't want to memorize this formula. I always found out when I was, that in the past that it's challenging to remember this very complex looking formula. But if I look at it in the guise of the Pythagorean theorem, it actually becomes something very simple to find out the distance between 2 points. So, with that being said, let's go and talk about the Pythagorean theorem. Let's not get too far ahead of ourselves. The Pythagorean theorem is a theorem that has been proven. It's probably one of the most proven theorems in mathematics. There's so many different kinds of proofs to this that they actually wrote a book about the number of proofs from this. There's over 100. Former presidents have written a proof, and all kinds of people have different proofs for this. It was developed by Pythagoras, ancient Greek, and here's what it says. In a right triangle, so you have to be in a right triangle. In a right triangle, it simply means a triangle that has a right angle or a 90-degree angle in it. If I have a right triangle and the sides are labeled as such, then I have this relationship between the three sides. I can take this distance and square it, add it to this distance that is squared, and I will always get that distance squared. Pythagorean theorem. Very, very famous, used constantly out in the real world. So what they've done to find the distance between here and here, okay, in general, we call this, if I have a segment I want to find, see, then that literally becomes the hypotenuse in the right triangle. So whatever segment you have, they'll give you the two endpoints, you draw that, and then you can make a right triangle. And because I have the right triangle, what is the distance of this side of the right triangle? Well, this point has an x, this point has an x, so you just subtract the x's. That'll be your distance. How far is it between 5 and 7? Well, I know it's 2, but mathematically, isn't it 7 minus 5? 7 minus 5 gives me the 2. So that's mathematically where I can do this for any points. Just take the right one minus the left one, and you'll always find the distance between the 2 points. And so that's what we do down here. You'll get x squared minus 1, x2 minus x1. Do the same thing for this side with the y values. So the y2 here and the y1 here. And so I have these distances. So according to the Pythagorean theorem, the distance of PQ, see PQ is a length notation. See how there's no line across the top. So PQ is the length of PQ squared, must be that quantity squared plus that quantity squared. And then to undo the square here, we take the square root, and that's how you get the distance formula that they give you. So if you want to memorize this formula and use this formula, they give you 2 points. You plug in, 1x minus the other one, and the y's, just subtract those. You'll be fine. You'll have the distance between the 2 points. Okay? And there is no problem with doing that. Here's what I do when I want to do this. It's the same process. I just don't memorize the formula. I'm going to use Pythagorean theorem. So you give me a segment, points, and I do a quick sketch. Now here I did a little bit better sketch because I used a graph paper. But I mean, I don't have, this does not have to be accurate at all. I have this point here, I have the numbers here, and then I make a right triangle. And then I find that distance. Well, I'm going from -5 to 3. I'm going from -5 to 3, that's a distance of 8. Right? 5 to here and 3 to here, that's 8. I'm going to go from -1 up to 2, so that's 1 plus 2 more is 3. So I know this distance is 8, that distance is 3, and I just do a Pythagorean theorem. So I know that this distance is the square root of 8 squared plus 3 squared. So I did this formula, I just didn't plug it into that formula. I'm drawing a picture to find these distances, and you would have to, if you do it this way, this is what you have to do to get your points. Otherwise, you got to use your formula. And then you work this out, and you get the square root of 73, and then you try and simplify, if possible. Okay. Draw a sketch, make a right triangle, find the side lengths, use Pythagorean theorem, take the square root of both sides, and simplify your radical, if possible. If you can't, then you're done. You circle it, you're done. So these are the two formulas that you're going to be asked to do in the next couple of lessons. I have some examples we're going to do. I have some examples we're going to do. And so let me pull those out, and we're going to do the midpoint of these, and I will show you how I would do them. Okay? So I want to find the midpoint of PQ. Here's P and Q. So what would I do? I would draw a quick sketch of this. And what I mean by quick sketch is, again, it doesn't have to be accurate. Just a general ballpark. I have a -2, 13. -2, 13. -2, 13. That is Q. 3, 5. 3, 5. 3, 5. That's P. There is my segment right there. I want to find the midpoint. Okay? So the midpoint is what? It's in the middle. So it's going to be in between 3 and -2. So I take the x's, add them, divide by 2. Take the y's. Since I started at this point, I should start the y's at this point. So it'll be 13 plus 5. Divide that by 2. Okay? And so then you clean these up and you get your final answer. So my midpoint M, -2 plus 3 is 1. It's 1/2. This is 18 divided by 2 is 9. There's my midpoint. It's at 1/2 and 9. So this point right here is the midpoint, 1/2, 9. And there you go. That's the midpoint. When you do this for work, I want to see that and I want to see that. Okay? This you should have to help you do your work properly, but that's up to you. I'm not going to draw the picture again, but for finding length, I definitely draw this picture. I'll just use the picture I've already drawn since I have it here. So the points is the same 2 points. So this time, since I want to find this length, I'm going to make a right triangle. Just like so. And then I got to find these distances. I'm going from -2 to 3. So -2 and 3, that is a distance of 5. I'm going from 5 to 13. 5 to 13, that's 8. So again, see, it's not drawn to scale. I mean, 5 is much longer than the 8 is over here. I don't care. It's just to get these numbers, right? I'm going from 5 to 13, that's an 8. I'm going from -2 to 3, that's a distance of 5. And then Pythagorean theorem over here tells me that PQ is going to be the square root of 5 squared plus 8 squared. See? And then you just clean this up and get a number. So the distance PQ, this is 25 plus 64. Okay? And 25 plus 64, I write this out here for you, 64. And then this is going to be a 9 and an 89. And so then the question is, can that be simplified in any fashion? Is there a perfect square that goes into 89? I don't believe so. I think I'm done with that one. So that is your final answer right there. So this would be the work I would want to see. If you did Pythagorean theorem this way, I'm sorry, the find the length this way, I do want to see a small sketch so that I know that these are the actual numbers that you're going to get. So you would draw me the sketch, show me the triangle with the numbers in it, and so forth. If you choose not to do this route, you choose the formula route, then it would look like this. You would put PQ equals the square root, and then you have to do x2 minus x1, so you can just do -2 minus 3 squared. Now, if you do it this way, you got to take the same point from the same point each time. So this is the q minus the p number, so this has to be a q minus the p number. It has to be that way. So these two numbers have to come from the same point. These two numbers have to come from the same point. It doesn't matter which one you start with, but you just need to make sure that you start with the same one each time. So that would look at that. Then you'll see that you have the same as this over here. So this is going to be a -5 squared plus 8 squared, 25 plus 64. And so then PQ is the square root of 89. So you can show me a picture of this to that, or you can do the formula, no picture, to this, to that. So that's how you would do this. So it's this way or this way. Okay, your choice. Choose what you like best. And so that's this. We're going to do a lot of examples in the textbook today. So we'll cover them some more stuff then.